Hey sir, I'm Rika Jane Cabusas, leader of Group 1. Our topic is Fibonacci sequence. In math, the sequence is defined as an order list of numbers which follows a specific pattern. The numbers present in that sequence are called the terms. In this topic, I will discuss the Fibonacci sequence definition, formula, less, and examples in detail. According to Arthur Benjamin, the Fibonacci sequence is a beautiful numbers of patterns they display. What is Fibonacci sequence? The Fibonacci sequence, also known as Fibonacci numbers, is defined as the sequence of numbers in which each number in the sequence is equal to the sum of two numbers before it. The Fibonacci sequence is given as 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Here the third term. One is obtaining by adding the first and second term. The first term is 0. And the second term is 1. 0 plus 1 equals 1, which is 1. 2 is obtaining by adding the second and third term. The second term is 1, and the third term is 1. 1 plus 1, which is 2. 3 is obtaining by adding the third and fourth term. The third term is 1, and the fourth term is 2. 1 plus 2, which is 3, and so on. For example, the next term after 21 can be found by adding 13 and 21. 21 plus 13, which is 34. Therefore, the next term in the sequence is 34. Here is the longer list of Fibonacci numbers. When we make squares with those widths, we get a nice spiral. Do you see how the squares fit neatly together? For example, 5 and 8 make 13. 8 and 13 make 21, and so on. Fibonacci sequence formula. Fibonacci sequence of numbers f sub n is defined using the recursive relation with the seed. Values f sub 0 equals 0 and f sub 1 is equals 1. F sub n is equals f sub n minus 1 plus f sub n minus 2. Here the sequence is defined using two different parts of such a kick-off and recursive relation. The kick-off part is f sub 0 equals 0 and f sub 1 equals 1. It is note that the sequence starts with 0 rather than 1. So f sub 5 shall be the six terms of the sequence.
Today guys, for today's video, we are going to discuss our assigned topic about Fibonacci sequence. So first of all, we are going to define what is Fibonacci sequence. So what is Fibonacci sequence? The Fibonacci sequence is a set of numbers that starts with a 1 or 0 followed by a 1 and proceeds based on the role that each number. This is what we call Fibonacci numbers and equal to the sum of preceding two numbers. So the Fibonacci sequence ends up like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on and so forth. As you can notice that each number in the sequence is the addition or sum of the two previous numbers. For example, 1 is the addition of 1 and the result is 2, and 1 is the addition of 2 and the result is 3. So that is the example of Fibonacci numbers. So not only in the number we can see the Fibonacci sequence, also in our real life. For example, the DNA of humans, the galaxy, and the seashells, and etc. That is the concept of Fibonacci sequence help us our daily life to appreciate things around us. For example, is the flowers in the garden. As we notice, the petals of every flowers shows the number patterns of Fibonacci. In this way, we appreciate flowers in high level because of its unique concept. So that's all.
Good day, sir. I'm Jane Spobadora Bihag from Section Foxtrot, first year Criminology. Our topic is all about Fibonacci sequence. I'm here to answer the following questions. 1. What is about is fully discussed on your assigned video. Answer. The Fibonacci sequence is formed by adding the preceding two numbers beginning with 0 and 1. Ratios of two Fibonacci numbers approximate the golden ratio, which is considered as the most aesthetically pleasing proportion. 2. What is about this concept? Cite a few more real words, cases, or examples that would show the concept. Answer. Fibonacci sequence equals 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13, 8 plus 13 equals 21, and so on. 3 is the obtained by the adding the third and fourth term, 1 plus 2, and so on. 3. What are your insights about these mathematical truths or sentences? Answer. Fibonacci is the one of the most famous names in mathematics. This would come as a surprise to Leonardo Pisano, the mathematician we now know by that name, and he might have been equally surprised that he has been more immortalized in the famous sequence. 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13. Rather than for what is considered this far greater mathematical achievement, helping to popularize our modern number system in the Latin-speaking world. That's all. Thank you.
Good day everyone, I am Jessa Lazarnacorius from Section Foxtrot, and today I will explain the math concept that fully discussed on our assigned video. It's about the Fibonacci sequence. And the Fibonacci sequence is a collection of numbers that begins with a 1 or a 0, then a 1 and continues based on the rule that each number, called a Fibonacci number, is equal to the sum of the two numbers before it. My insights about mathematical truths or certainties that learning mathematics have three reasons also to apply at Fibonacci sequence, which is calculation, application, and inspiration. And now, I will cite the example of Fibonacci number. These are the example of Fibonacci sequence. Looking at it, you can see that each number in the sequence is the addition or sum of two previous numbers. So, 0 plus 1 equals 1, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, 8 plus 5 equals 13, 13 plus 8 equals 21, 21 plus 13 equals 34, and so on. And these are the examples.
Good day, sir. My name is Joanna Maria Guanza from Section Foxtrot. Our topic is about Fibonacci sequence. Why do we learn mathematics? There are three reasons in mathematics. It's calculation, application, and inspiration. Question number 1. What math concept is fully discussed on your assigned video? The following discussion of our topic is all about Fibonacci sequence. This number can be appreciated in many different ways. From the standpoint of calculation, they are easy to understand. For example, 1 plus 1 is equal to, then 1 plus 2 is equal 3, 2 plus 3 is equal 5, and 3 plus 5 is equal 8. The question number 3. What are your insight about these mathematical thoughts and or certains? Now, as much fun as it is to discover these patterns, it's even more satisfying to understand why they are true. And question number 2, what is about the scope? Cite a few real words, cases, or example that would show the concept. And this is the answer of question number 2. 1. Square root is 1 is 1. Square root of 2 is 4. Square root of 3 is 9. And square root of 5 is 25. Square root of 8 is 64. And square root of 13 is 169. And 21 squared is 41. And 34 squared is 1156. And square root of 55 is 3025, and so on.
Hello guys, the video is about Fibonacci sequence, and it is formed by adding the first two terms. And from there, each term is found by adding two previous terms. Hello guys, this is the example of Fibonacci sequence that I watched earlier, and this is what he did. It's like 1 plus 1 equals 2. 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13. All you have to do is follow the patterns just by adding two previous numbers. And the second part is he is using squares in the patterns. So like, the square root of 1 is 1, the square root of 2 is 4, the square root of 3 is 9, the square root of 5 is 25, the square root of 8 is 64. All you have to do is follow the patterns. And this is the interesting part in using square root in these patterns. Like 1 plus 1 equals 2. 1 plus 4 equals 5. 4 plus 9 equals 13. 9 plus 25 equals 34. And honestly, it takes me 5 minutes to figure this out. And what he did in the third part is adding these numbers. It's like 1 plus 1 plus 4 equals 6. 1 plus 1 plus 4 plus 9 equals 15. 1 plus 1 plus 4 plus 9 plus 25 equals 40. 1 plus 4 plus 1 plus 1 plus 4 plus 9 plus 25 plus 64 equals 104. Right? And this number came from the number that I squared earlier. Look at these numbers. This is not a Fibonacci numbers, right? But if we look at within them, we can see the Fibonacci numbers. It's like 2 times 3, and it's the same in here. And 3 times 5, and it's the same again. And 5 times 8, and 8 times 13. We can see them in here, right? And this is the interesting part about Fibonacci sequence. Math is the study of pattern. Studying pattern is an opportunity to observe, experiment, discover, and create. Because there's a lot of things we need to learn about math. We need to know about math, and that is the interesting part in math to discover.
Good morning, sir. Good morning, classmate. My name is Gypsy Bana from Section Foxtrot. I'm here to report my topic entitled Nature, the Golden Ratio, and Fibonacci. The following topic in the video I watched is all about Fibonacci numbers, and it is related in my topic right now because our nature, it related in natures like we see everywhere. What is about this concept? Okay, the golden ratio 1.618034 is also called the golden section or the golden mean or just the golden number. It is often represented by a Greek p, with a small p is just the decimal part of p, namely 0.618034. If we take the ratio of two successive numbers in Fibonacci series is 1, 1, 2, 3, 5, 8, 13, and we divided each by number before it, we will find the following source of numbers. Example of this is 1 divided 1 equals 1, 2 divided 1 equals 2, 3 divided equals 1.5, 5 divided 3 equals 1.666, 8 divided 5 equals 1.6, 13 divided 8 equals 1625. 21 divided 13 equals 1.61538, and that's all. We just only divide it in the golden ratio. Example in nature in golden ratio is we see many plants show the Fibonacci numbers, just like petals on flowers. Like buttercups have 5 petals, lilies and iris have 3 petals, some dilipiniums have 8, corn marigolds have 13 petals, some asters have 21, whereas disease can be found with 34 or 55 or even 89 petals. Let's proceed in Fibonacci sequence. The Fibonacci sequence always begins with the numbers 0 and 1 like this: 0, 1, 1, 2, 3, 5, 8, 21, 34, 55, 89, and 144, and so on and so forth. As we can see that each numbers in the sequence is the addition or sum of the two previous numbers. For example, 34 is the result of 21 plus 13. For example, should we for short, we should add only. In nature, as we observe that many of the natural things follow the Fibonacci sequence, it appears in biological settings such as branching in trees, Pilatoxis, or arrange the leaves on the branches, flowers, and petals, or the fruit sprouts of pineapples, the flowering of articles on uncurling fern, and the arrangement of pine cones bracts. Another example in which given by the number of Fibonacci sequence in nature is given by the number of petals. Parnosaur rose hips have 5 petals. Cosmea have 8 petals. Disease have 13 petals. Chicory have 21 petals. And Asteraceae have 34, 55, or 89 petals. What are your insights about the mathematical truths or certainties? Okay. My insight about this topic is one of the most popular mathematical concepts that involves in our natures, like plants or trees, and others that we have a Fibonacci numbers that we see everywhere. That's all.
Good day, I am Mary Jo Barbarino from Section Foxtrot, BS Criminology, first year. This video presentation is about the Fibonacci sequence. Question number 1. What math concept is fully discussed on your assigned video? The math concept that fully discussed about our assigned video is about Fibonacci sequence. Fibonacci sequence is a set of numbers that starts in 1 or 0, then followed by 1 and so on. It is about to know how to get the followed numbers or how to solve to get the following numbers. Question number 2. What is about this concept? Cite few more real-world cases or example that would show the concept. It is about how to get the followed numbers. Example that should show the real-world cases about Fibonacci sequence is the petals of flowers. Number of petals in flowers are consistently follow the Fibonacci sequence. Question number 3. What are your insight about these mathematical truths or certainties? My insight about these mathematical truths or certainties is to find a way or a solution to solve the numbers that follow each numbers written.
Muna akong maidungag sa Fibonacci number. Karang nagtawag ani sa Fibonacci number kay si Leonardo Epesa. siya nagtawag, murag siya naghimo sa Fibonacci number ba. Tapos ang nabalaan ako sa Fibonacci karang added, ba 1 plus 1 plus 4 equals 6. Tapos murag kuan lang yapon siya sa times good. 1 plus 1 plus 4 plus equals 6. Tapos 2 times 3 equals 6. Murag kuan lang yapon siya sa times ba. Murag kapareha lang yapon sila. Murag to. Ang oras to.
My name is Jomar Diamar, Section Foxtrot. My report is Fibonacci sequence. Number 1 question. What math concept is fully discussed on your assigned video about the Fibonacci numbers? Number 2 question. What is about this concept? Cite few more real-world cases or examples that would show the concept. Fibonacci numbers are used to create technical indicators using a mathematical sequence developed by Italian mathematician, commonly referred to as Fibonacci. The 13th century, the sequence of numbers starting with 0 and 1 is created by adding the previous two numbers. For example, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13, 8 plus 13 equals 21, 13 plus 21 equals 34, 21 plus 34 equals 55, 34 plus 55 equals 89, 55 plus 89 equals 144, 89 plus 144 equals 233, and 144 plus 233 equals 337. Number 3 question. What are your insight about these mathematical truths or sentences? My insight about this topic is one of the most famous formula in mathematics. Its number is the sequence is the sum of the two numbers that precede it. It's been called nature's secret code and natural universal rules. Just take a look at the pattern it creates and you can instantly recognize how the sequence works in nature, like an underlining universal grade.
Good day, sir. I'm Anatalio Imbalicog III from Section Foxtrot. Today, I'm gonna explain the report of Fibonacci sequence. The Fibonacci sequence is a set of numbers that starts with a 1 or a 0, followed by a 1, and proceeds based on the rule that each number called a Fibonacci number. Fibonacci number is equal to the sum of the preceding two numbers. The concept of Fibonacci sequence help our daily life to appreciate things around us. For example is the flower in the garden. As we notice, the petals of every flower shows the number patterns of Fibonacci. In this way, we appreciate flowers in a high level because of its unique concept. My insight about Fibonacci sequence is a sequence of number in which successive number in the sequence is obtained by adding the two previous number in the sequence. The sequence starts with 0 and 1 and proceeds forth as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. That's all, sir. Thank you.
Hi, my name is Labrino Anak Nito, first year Criminology, section Foxtrot. Number 1. What math concept is fully discussed on your assigned video? Answer. Understanding a math concept is different from knowing a math fact, but both are important. Learn the definition of those two terms as well as how. Number 2. What is about this concept? Cite few more real-world side of example that world showed the concept. Answer. In the simple terms, a concept is a name of label that regards or terms an abstraction as if it have concept or material existence. Number 3. What are your insights about these mathematical truths or scientists? Answer. To whatever extent they are available to put truth in at the beginning, math allows one of drive consistent result.
Good day, sir. I'm Danilo Alamban Jr. from Section Foxtrot. Today, I am going to answer the 3 guide questions about the Fibonacci sequence. So, question number 1. What math concept is fully discussed on your assigned video? The concept discussed on my assigned video is the Fibonacci sequence. The Fibonacci sequence is a set of numbers that starts with a 1 or a 0, followed by a 1 and proceeds based on the rule that each number is equal to the sum of the preceding 2 numbers. Question number 2. What is about this concept? Cite a few more real-world cases example that would show concept. The Fibonacci sequence is one of the most famous formulas in mathematics. Each number in the sequence is the sum of the 2 numbers that precede it. So the sequence example 0 plus 1 equals 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5, and so on. So question number 3. What are your insights about this mathematical truth or certainties? My insight about mathematical truth in the Fibonacci sequence is a sequence of numbers in the which each successive number in the sequence is obtained by adding the 2 previous number in the sequence. That's all. Thank you.
So hi, I'm Mirjor and Miss Bailey. So we'll explain the assigned video of our group. So what concept it's full discussed in your assigned video is about Fibonacci numbers. So ang Fibonacci numbers is mo siya. 1 plus 1 equals 2, 2 plus 3 equals 5, 5 plus 6 equals 30, and so on. So mo siyang Fibonacci numbers. Ang Fibonacci numbers daw is ma-appreciate sa tanan. So next is what is about this concept. Cite few more real causes or examples that will show the concept. So mo siya. So according sa video na akong gitanaw is naagid siya example sa Fibonacci numbers. Naagid siya concept sa Fibonacci numbers, which is ang bulak daw and I to 8 Fibonacci numbers. And then ang pinya daw ug ang sunflowers has a spiral 34 Fibonacci numbers. So mga siya. So next is about what are your insight about this mathematical truth or sciences? Para sa ko ang pananaw is tinuod gud siya. So kabalik so matanong ko sa palibot, lagi siya Fibonacci numbers kung ihapon sa nako, di ba? So ang numbers sa
Good day everyone, my name is Isandi Abajis from the section Foxtrot, and our topic for today is all about Fibonacci sequence. Fibonacci sequence is a series of numbers that follow a unique integer sequence. These numbers generate mathematical patterns that can be found in all aspects of life. Leonardo Fibonacci is an Italian mathematician who discovered this very special sequence of numbers, which is known as the Fibonacci sequence. I will give you the example of Fibonacci sequence in mathematics. 2, 5, 8. There are many examples of Fibonacci. These numbers follow a pattern of each numbers that equals to the sum of the preceding 2 numbers. let me give you the examples and important of Fibonacci sequence in real world cases. One of very known example of this is the number of petals in a flower consistently follows the Fibonacci sequence. Fibonacci numbers also found in DNA, galaxy, seashell, and etc. We can observe that many of the material things are not that many of the natural things that follow the Fibonacci sequence. Therefore, we can conclude the God is very intelligent and creative God.
Albano, section Foxtrot. What must accept in your discussion is in your segment of video. Understanding a math accept is different from you a math facts both of important learn to definition. What about is concept? This new more learn to word using explanation to word show that concept. The learn word is the placed in the wish and stability most live and the primary tense which we want actually most daily. What are the significant about this mathematical turns or contraction? Mathematical collision concept of deduce mathematical supposition that are objective worldly pretending as true or the list of logical living and concept can be shown to be count on yourself correlative